In this video, I introduce the CenterNet anchor-free object detectors. Without using predefined anchor boxes, CenterNet is an anchor-free object detector, which detects an object by using a single point, namely center of a bounding box. A keypoint estimator is used to find the center point and regress from the center point to other object properties, such as object bounding box, as shown here. CenterNet uses the image as the input to a backbone network that generates a 2D heat map, as shown here. Peaks in the heat map correspond to object centers. Features at each peak are used to predict the height and width of object bounding box. CenterNet uses a W by H image as the input to generate a key point heat map Y hat, where R is output straight and C is number of object categories. Y hat XYC is 1 indicates a key point of category C at location XY, while Y hat XYC is 0 for background. A 2D Gaussian kernel describes the probability of a heat map point XY being the ground truth, as defined here, where P tilde is the center of a ground truth in heat map, and sigma square is object size adaptive variance. The focal loss LK of a key point estimation is defined as here, which regress Y hat XYC to Y XYC, where alpha and beta are hyperparameters and n is the number of key points. A local offset O hat is used to recover discretization error caused by output straight R. The offset loss error off is defined here. The supervision performs only at the key points tilde P, and all other locations are ignored. Suppose that X1, Y1, X2, Y2 denotes a bounding box of object key with the category CK with the center at PK. A key point estimator Y hat is used to predict all center points that are regressed to the object size SK. Loss L size for bounding box S hat at the center point is defined as here, where SK is the ground truth bounding box. The overall training objective is defined as a sum of 3 terms, where lambda size and lambda off are the width for size loss and offset loss respectively. A single network is used to predict the key point Y hat, offset O hat, and size S hat, as shown here. CenterNet predicts C plus 4 outputs at each location where C is number of object categories and number 4 represents the coordinates of the object bounding box. Here are architecture and the pipeline of CenterNet. This is the input image, this is the backbone network, followed by 3x3 convolution, ReLU nonlinear activation function, and 1x1 convolution. 3 heads are used to predict the key points, size of bounding boxes, and offset O hat. The final result is a bounding box for each actual object in the input image, as shown here. For more details, please check with these references. Thank you. Bye.